Okay, hi guys. This is the final segment of our 2.5 Exponent Laws 2 called Power to Power Law. Okay, so we're going to define what power to power law really means. Okay, well, I'm just going to demonstrate how this happens, okay, with an example. So we're going to, again, if the question asks you to just write as a power, then your final answer will just have a power, a base with an exponent on it. Okay, so let's try at the same time. We're going to try to define what power to power law really means or how it happens. So for example, so let's say you have a power 2 to the 4. Now we're going to turn this into a base, and we're going to give this power an exponent to the 3. I know it looks really weird, but there is a way to define this, and you'll see what happens to these exponents when I demonstrate this. Okay, so what's going to happen to this? How do I rewrite this as a repeated multiplication? Well, if our base is 2 to the 4, then we're going to take 2 to the 4 and I'm going to multiply it to itself 3 times, like so. Okay, so there's our repeated multiplication of our base 2 to the 4, because it is the exponent of 3, so multiply it to itself 3 times. And then I'm going to further expand this to split this 2 to the 4 into its repeated multiplication, which is going to be 2 times 2 times 2 times 2. Okay, that's this first 2 to the 4. And then I'm also going to multiply it by this 2 to the 4, which is going to be 2 times 2 times 2 times 2. And then I'm going to further multiply that with this 2 to the 4, which is, guess what, 2 times 2 times 2 times 2. That's a whole lot of 2's to multiply. I think it would be much more convenient to write it as a power. Well, if you want to count with me, how many 2's are there that we're multiplying here? We got 4, 8, we have 12. So now you want to rewrite this as a power, then this will be 2 to the 12.
Can I borrow a blue marker?
So now, do you notice what you did with these exponents here? You have a 4 here and a 3 there, and all of a sudden you have a 12 here. Maybe you just multiply the exponents, perhaps. Okay, maybe we'll try that again. How about we try something simpler? Um, let's say 3 to the power of 2, all this to the power of 4. Okay, what does that look like as a repeated multiplication? Well, our first base is 3 to the 2, so we're going to multiply that to itself 4 times. Okay, and then I'm going to further split these guys up into their repeated multiplication, as in 3 times 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 3. Wow, okay. So now we're multiplying this many 3's. How many 3's did we multiply all together? 2, 4, 6, 8. So now rewriting this as a power, this is 3 to the 8. And again, look, just like the first example, it looks like, if you guessed it, all you're really doing is multiplying these exponents in the power to power rule. So 2 times 4 is equal to 8. Okay? So maybe we can write that as the power to power law, because essentially that's what it really is. Okay? Power to power law states that when raising a power to a power or an exponent, then you simply multiply the exponents. Okay? In other words, in general, if you have a to the m and you're going to raise it to the power of n, then this is simply equal to a to the m times n. Okay? And a is an integer. Okay? And m and n are whole numbers. Okay? And now let's try to evaluate some examples here. Okay. So in other words, our next exercise or example is to evaluate. In other words, this time we're actually going to calculate, not just leave our answer as a power, but we're actually going to calculate it and see what answer we get in the end. Okay. How about this first one? I hope you guys still remember what zero exponent laws are. Okay, anything the exponent of 0 is equal to 1. Well, this one should be nice and quick. This is all equal to 1. But if you really want to go through the step, 12 to the 8 times 0 is equal to 12 to the 0, which is equal to 1. Next example. Let's try here, negative 4 to the power of 2, all this to the power of 2. What is this going to look like? Well, our base is still negative 4, and our exponents are 2 and 2, so you just multiply those 2's. So negative 4 to the exponent of 4 is equal to negative 4 to the 4. Again, going back to our calculator, I'm hoping from the last video you were able to view this. In this calculator, to turn this 4 into a negative, there's a negative button right here. So there's our base, and the exponent button is right here. Exponent of 4 is equal to 256, positive 256. Okay, maybe one last example. Okay, what is negative all this to the exponent of negative 5 to the 2, all this to the exponent of 3. Wow, okay, looks kind of crazy, but let's take it easy. Don't get bothered by this negative in the end here. This guy is just a hangers on. So whatever we calculate over here, this negative essentially just turns it to its opposite, okay? But what I'm going to do is I'm going to carry that negative throughout my calculation. Well, that negative now is going to be, still keeping them outside this bracket, but it's going to be negative 5 to the 2 times 3, okay? So negative 5 to the 6. And negative 5 to the 6 is, pardon me, the exponent of 6 is positive 15,625. And guess what? That 15,625 gets turned into a negative. Okay? And congratulations, this is that was the last segment of our 2.5 Exponent Laws Part 2. And so I hope these videos do help you with your assignment, and I wish you all luck. Bye for now.